Today's seminar is going to focus on converting between units using dimensional analysis, and our goal for this lesson is going to be, I can convert between units using dimensional analysis. So at this time what I would do is go ahead and write this title in your notebook and also put the goal in your notebook as well. Next, what you'll need to take out is your how to convert between units using dimensional analysis. And this will give us our steps to tell us how to convert between different units, and specifically by using dimensional analysis. So you might be thinking, what is dimensional analysis? Well, what it is, and what it does is it converts one measure or rate to an equivalent measure or rate with different units by multiplying by one or more conversion factors. So, once again, what dimensional analysis does is converts one measure or rate to an equivalent measure or rate with different units by multiplying by one or more conversion factors. And once we get into examples, we'll understand what this actually means and what we're doing. And down here, the different steps to convert are determine what units are given first. So when you're starting a problem, you're going to have units that are given right away. So we'll determine what those are, and those should be easy to find. Next, you want to determine what units you will need. So what are we trying to get to? What are we starting with? And what are we trying to end up with? Next, we'll have to determine our conversion factors, or determine your conversion. Determine your conversion factors. And sometimes you may have one factor that you need to use, and other times you may have 3 or 4. It just depends on how far the conversion needs to go. Your next step would be to align your conversion factors so they cancel. And we'll see what that means once we get into some examples, but you want to make sure that they cancel. And if necessary, in this next step here, use your calculator. And you may need to at certain times, because sometimes you may have a really big number divided by another number. I don't expect you to do that out on paper. You can use a calculator, but only if necessary. If you don't need it, don't use it. And last but not least, you want to check your answer for correct units. So again, the steps that you need to use are determine what units are given, determine what units you need, determine your conversion factors, so figure out what you need to multiply by in order to get the units that you need. Next, you would align those conversion factors so that they cancel each other out. They only cancel when one's in the numerator and one's in the denominator. And you'll see more with that when we get to examples. Use your calculator to determine your final answer, and once again, only do that if necessary, and then check your answer for the correct units. And really, that's all that there is to this. The hardest part is probably figuring out your conversion factors that you need, but otherwise, it's just a multiplication problem. So this sheet, once filled out, should go in your notebook as well, so that you can refer to this whenever necessary. So next, you'll need your actual foldable for your notebook. And on the front of here, we have all the different conversions that you could possibly have. And you will also have a pink sheet too as well with different conversion factors. And these will be very helpful when determining what your conversion factors should be in the problems that you're using. So make sure that both of these get into your notebook as well. Now, before we jump into doing examples, what I would like to do first is look down here at our metric system, because this table might be a tad confusing. So, first and foremost, I want you to put a big 1 in front of this table, because all of these are referring to one of these. So, 1 kilometer, 1 kilogram, 1 kiloliter, something like that. Okay? So just one of those. And the cool thing about the metric system is that it's just based around units of 10. So no matter if it's kiloliters, kilograms, kilometers, decimeters, decigrams, deciliters, whatever it might be, they're based around 10. And it's just a matter of moving a decimal place to getting to the conversions between those. So it's a little bit nicer than the American units that we use, or standard units, I should say. So also over here with this curly bracket, I'm going to put the different forms that this can take. So like I said, it could be kiloliters, it could be kilograms, and it could be kilometers. So just a quick note before you jump into doing your actual conversions. And like I said, you have your units of length, your units of mass, units of volume and capacity, as well as units of time, and then your metric system down here as well. Once again, you also have this pink sheet with all these different conversion factors that you can use, and we might refer to both as we're working through the problems within your foldable. So that brings us to the next part then. So let's start to work within the foldable. We have 5 problems that we're going to use. And when solving these, I do want you to use dimensional analysis. You will come across dimensional analysis in later math classes as well as science classes, and this is really the most efficient way to do this and the most organized way to do it. So I'm going to stress that you use this method. Okay, so we may need to have this out again for our steps. So have that out. So first problem here, convert your teacher's age to seconds. Well, first of all, we're going to need to know what my age is. My age is 27 years. So our factor here, what we're going to be converting to, is going to be from years to seconds. So we're going to have to break this down piece by piece. We're going to have to determine what conversion factors we need, and we'll do that in a second here. So first and foremost, determine what units are given. We have years. Years are given to us. We need to determine what units you need. So after we carry out all of our multiplication that we'll do, we want to get to seconds. So in this box over here, we should end up with seconds. And also when we are doing our conversion factors and when they cross out in the numerator and the denominator, like this note says up here, we should end up with only seconds left. If we don't, then we probably did something wrong and need to go back and double check our work. Now we need to determine our conversion factors. So we're going to break this down step by step. So if I think about years, the next thing that I think about is days. We're going to use something called the fence post method to work through these. So basically, we're going to separate our conversion factors with a vertical line. Now we want years to cancel, so we want years to be in the bottom. So we would say 1 year, I'm going to abbreviate these, is how many days? Well, it's 365 days. Now we can see here that based on this rule up here, write each conversion factor so the units in the numerator cross out with the units in the denominator. So far we would have years cancel. So let's keep moving along here. Now if we're thinking about days, if we go to our front page here real quick, so we went from years. We could have went to month, but I know that there's 365 days, so we just went to that right away. Once again, if you understand your conversion factors, sometimes the problem can be quicker. But we went to 365 days, So we kind of skipped these up here because they're not necessary. We know there's 365 days in a year. So next I would go from days to hours. So I would say, so remember our conversion factor, they need to cancel out. So 1 day is equivalent to 24 hours. And then similarly, we'd want to go from hours to minutes. So 1 hour is 60 minutes. And then from there, we could go from minutes to seconds. So 1 minute is 60 seconds. Okay, so I'm seeing seconds in my answer, so I'm going to stop there and see if all my units cancel out and give me seconds at the end. So years should cancel. Remember, write each conversion factor so the units in the numerator cross out with the units in the denominator. So years will cancel here. Days will cancel. And we're just canceling the units. We're not canceling the numbers because we want to use the numbers. Cancel hours. And then minutes. And now I'm going to look at this. What unit is left? Well, seconds. That's what we're trying to convert to. So we have seconds here. So now what I need to do is I need to multiply across the numerator as well as the denominator, and that should give me my final answer. What's neat about this is that we're really multiplying by 1 each time. Because if we think about these units that we have in here, they're really 1-to-1 ratios. Because 365 days is equal to 1 year. That's a 1-to-1 ratio. Same thing with 24 hours is 1 day, 60 minutes is 1 hour, 60 seconds is 1 minute. They're all equivalent to each other. So really, we're just multiplying by 1 all the way through in order to change our units. But we have to use the numbers that are here in order to help us out. So what I'm going to do quick is use my calculator, and you can use one as well when you're doing these, whenever necessary. 27 times 365 times 24 times 60 times 60. That gives me a grand total of, we'll put commas in afterwards, 851472000. Let's put our commas in then. So your teacher, in terms of seconds, has been alive for 851,472,000 seconds. That's pretty old. If you want to try to convert your age to seconds, you could absolutely try that. But for the time being, let's keep moving along with the problems here. So we're going to follow the same steps, but now we're going to convert quarts to ounces. So let's think about our steps here again. So determine what units are given. Well, we know we have 8 quarts to start. So 8 quarts to start, and we want to get to, so number 2 here, determine what units you need. We want to get to ounces. So at the end, we should end up with ounces as the only unit that's left, because that's what we want to convert to. So I'm going to drop my fence post in here and figure out what's the next logical step here. So we know we want to cancel out quarts based on this rule that we have up here. Set them up so that the numerator crosses out the denominator. Quarts will cancel here, but now we need to figure out what conversion factor we need to work with. So we're starting with quarts. So we know 1 quart is equal to 2 pints. So I'm going to set that up. 1 quart is 2 pints. Now I'd want to change from pints to whatever the next conversion factor is. This tells me that 1 pint is equal to 2 cups. And remember, our goal is to get to ounces, so I'm just working down this list based on where I started. So I said 1 pint is 2 cups. So 1 pint would go on the bottom so that those will cancel. and that's 2 cups. And then last but not least, I'm going to flip to the front again. 1 cup is 8 ounces. So 1 cup is 8 ounces. So I'm going to stop there because I see ounces in my equation I have set up here, or this problem, this multiplication problem I have here. So I'm going to go through now and figure out what unit factors, or I'm sorry, conversion factors cancel, and see if I end up with ounces as the only one left. If that's the only one left, then I more than likely set up my problem correctly. So quarts cancel, pints cancel, cups cancel. So it looks like I'm left with ounces. So what I need to do is multiply across the numerator, multiply across the denominator, and that should give me my answer. So 8 times 2 times 2 times 8 is 256. So I know that 8 quarts is equivalent to 256 ounces based on using these conversion factors. And using this dimensional analysis process, you should be able to convert between any type of units because it works out nicely. As long as you know the different conversions, this is a great way to work through this. It's very organized and very logical. All right, let's move to number 3 real quick. So convert 500 meters per second to miles per hour. This problem is a little bit different as we have to convert 2 different units of measure. We need to convert meters to miles and seconds to hours. Now it doesn't matter which one we do first because we're doing multiplication, and multiplication is commutative, so it can go anywhere. We just have to make sure we're setting up our units the correct way, following this rule, so that one's in the numerator and one's in the denominator so that they cancel each other out. So let's look at our green sheet here real quick. First rule, determine what units are given. So we know we have 500 meters in 1 second. Now we should set that up as a ratio that looks like a fraction. Remember, ratios can be written 3 ways, and a fraction is one of those. So 500 meters in 1 second. So I'm going to go ahead and use my fence post method, drop my line in here. Like I said, we can convert seconds first, we can convert meters first. It doesn't matter as long as things cancel correctly. So what I'm going to do first is convert meters. It's the first thing that I want to do. So what I'm going to do then is, I know I want to put something dealing with meters in the bottom. Now I don't have a straight conversion from meters to miles. Some of you may know that conversion and you could absolutely use that. So I'm going to use what I know here. And I know that 1 kilometer is 1,000 meters. And then I also see down here that 1 kilometer is, or 1.609 kilometers is 1 mile. So I'm going to use both of those factors to help me out here, starting out with meters to kilometers first. And what I know is that there are 1,000 meters in 1 kilometer. So that's going to be our first conversion factor here. Next, I'm going to go from kilometers to miles. And I know what that conversion is because I have it on this pink sheet here. I know that 1 mile is equivalent to 1.609 kilometers. So I'm going to set that up with the 1.609 kilometers in the denominator so that the kilometers will cancel, and I know that's equivalent to 1 mile. Now, miles is the length that I want to convert, so it looks like I have that. But now I need to continue and change seconds to hours. So this is a multi-step conversion here because we have 2 different rates or 2 different units that we need to convert. So if we're working from seconds to hours, the next thing I would want to do is do seconds to minutes. Now since seconds is in the denominator here, it needs to be in the numerator in order to cancel. So I know that 60 seconds is equivalent to 1 minute. So this one's a little bit bigger. And next I know that 1 minute is equivalent to, 60 minutes is equivalent to 1 hour. So I kind of messed up on that one. 60 minutes is 1 hour. So I see that I'm ending up with hours, and that wants to be in the denominator. So I'm going to go through now and check and see if things cancel out enough to where I have hours or miles and hours for my last units. So let's start with the meters. Let's do that first. Meters cancel. Numerator, denominator. Kilometers cancel. Numerator, denominator. And it looks like I have miles because there's nothing else here that has miles that I can cancel the miles unit out with. So I'm going to go back to the beginning and work on canceling out the time units. So seconds will cancel with seconds. Denominator, numerator. As long as they're opposite of each other, they'll cancel. Minutes, those cancel out. And it looks like I'm left with miles per hour. So what I need to do now is multiply across the numerator and the denominator and do any division if necessary, because I want to have how many miles per 1 hour. And we might end up with a certain number of miles per multiple hours. So we need to make sure we reduce that to 1 hour, which just requires division. So I'm going to multiply 500 by 60 and by 60. That gives me 1, 8, and 5 zeros. 1, 2, 3, 4, 5. Throw my commas in. Me 1.8 million miles in, I need to do 1,000 times 1.609. That would be 1609 hours. So that says 1,800,000 miles in 1,609 hours. Well, I want to know how many miles per 1 hour, so I need to divide 1,800,000 by 1,609. So I'll do that on my calculator. And I get 1,118.7 miles per hour. In this case, I'm going to round to the 10th. Whatever your problem is asking for, you need to round to that necessary number if it doesn't work out evenly. So 500 meters per second is equivalent to 1,118.7 miles per hour. So what I'd like you to do is pause the video here and try these last two problems, so converting tons to grams and feet to kilometers. So please make sure you're referring to your conversion chart that you have on the front of your foldable here, as well as this pink sheet. So go ahead and pause it this time, try those two, and once you unpause, I'll go through the two problems that are listed below. Okay, so you should have given both of these a shot using the dimensional analysis that we've been working with the first three problems. So let's take a peek at this one here. Convert 17 tons to grams. So going back to my green sheet with how I do this, determine what units are given. I'm given 17 tons. And I want to convert that to grams. So put a G here for grams. So drop my fence post in. So we're going to use that method. And first and foremost, I'm thinking, well, I'm at a really big unit right now, and I need to go to a really small unit. So thinking about tons, I know that there's 2,000 pounds in 1 ton. And I think we have that on the front here. Yep, 2,000 pounds is 1 ton. So I'm going to set this up in order to cancel tons. So 1 ton is 2,000 pounds. Tons will cancel. Now I think I have a conversion where I can go from pounds to grams. And this might be on my pink sheet, but I'm going to look at this here real quick. Pounds to grams. So here they say 454 grams in 1 pound. Your other sheet says 453.6. There's different conversions. Some people round up. I'm going to use the one on your pink sheet, the 453.6. It's probably a little bit more accurate. If we round, we might not be as close to the actual answer. Since we're converting between standard units and the metric system, there's going to be some variation there because they're not nice units like the metric system is. So based on that, I know that this pink sheet tells me that there are 453.6 grams in 1 pound. So I want to cancel pounds. So I know that needs to be on the bottom. 1 lb, or 1 pound, is 453, 453, not 6, 453.6 grams. That's a 3. Sorry if that's confusing. So I see grams. My mind should be kind of going off that, hey, you have the unit that you need. So let's see if our units cancel, our conversion factors cancel. So tons cancel. Pounds cancel. We're left with grams. That's what we're trying to get to, so it looks like we did everything correct. So what we need to do now is multiply all the numerators, all the denominators, and that should give us our final answer. We may have to do some division if we were left with something like the last problem. So make sure you're doing that if necessary. So let's do 17 times 2,000 times 453.6. It's quite a big number. So 1, 5, 4, 2, 2, 4, 0, 0. Let's go ahead and put our commas in. So what this tells me is that 17 tons is equivalent to 15,422,400 grams. Now that makes sense because we went from something that's really big to something really small. So 15 million would make sense here. Sometimes you have to think about, well, does my answer make sense? And in this case, to me, it does because tons is big, grams is small. If we have a lot of tons, we should end up with a very big amount of grams. All right, then last but not least, let's look at 1,000 feet to kilometers. So we're looking at a conversion of distances here. So, like this sheet says, we're looking at what units do we start with. We're going to write those down. So I'm starting with 1,000 feet, and I want to end up with kilometers. So step 2 is what units do you need? We're trying to get to kilometers, from feet to kilometers. Next, we determine our conversion factors, but first I'm going to set up my fence post method here for doing my dimensional analysis. Now, kilometers, I'm thinking, well, that's close to miles. So what I'm going to do is change from feet to miles first in order to get to this. So I know that, and this is on the front, you have this, 5,280 feet is 1 mile. So let's go ahead and do that first. So 5,280 should be on the bottom because that's feet. We want the feet units to cancel, and that's equivalent to 1 mile. Now let's set up for our second unit here. Now, based on my pink sheet, I know that 1 mile is 1.609 kilometers. And that looks like that's going to be the fastest path to get to kilometers. So what I want to do then is say that 1 mile, that would be on the bottom because we want miles to cancel, is 1.609 kilometers. So I'm seeing kilometers. That's telling me that, hey, maybe you're done and you don't have to use any more conversion factors. So I'm going to see if what cancels now and see if I'm just left with kilometers. So feet should cancel. Miles will cancel. Remember, we're referring to this rule that's up here. Write each conversion factor so the units in the numerator cross out with the units in the denominator. That's very big here. If you don't put them opposite of each other, they won't cancel. So let's go ahead then, and it looks like we're left with kilometers, so we can carry out the multiplication and division if necessary. So 1,000 times 1.609 would give me 1,609. Probably didn't need my calculator there, it's just a matter of moving the decimals since I'm multiplying by 1,000. So 1.609, and we know that's kilometers right now, or I'm sorry, 1,609, and that's divided by 5,280. We don't have any units on that anymore, so I'm not going to put anything there. Now we just want to know how many kilometers this is, so we need to divide this answer here because it's not looking pretty right now. 1,609 divided by 5,280, and that gives me 0.304. I'm just going to round it to the nearest hundredth, so that would be 0.30 kilometers. And that makes sense because kilometer is pretty close to a mile. We only have 1,000 feet. There's 5,280 feet in a mile. So something under 1 makes sense here. So these are just a few examples that we went through today. Use this as a reference whenever working with this topic in ALEKS, or if you're doing it on a weekly assignment, something like that. This is just one way to go through the conversion factors. If you know a quicker path to it, use it. Sometimes you don't need all the steps. But if you're just starting out and you don't know all your conversions, use your charts that I gave you and set these up so that they're complete. As time goes on, you might see different conversions that are quicker, but for the time being, just go ahead and use what you know. And once again, make sure you're referencing your conversions here on the front of this foldable, as well as on this pink sheet. And don't forget to put all 3 of these in your notebook. These will come in handy when working with any type of conversions. So once again, just referring back to our goal and what we were doing today. Today we were working on converting between units using dimensional analysis. Our goal was I can convert between units using dimensional analysis. Hopefully after watching the seminar, this topic is making a little bit more sense. And as always, if you have any questions, please feel free to ask.